We are now going to begin your modeling max and min problems video. So with these types of questions, there are word problems where you have to find the maximum value or the minimum value, just like you did with projectiles, tossing a ball or kicking a ball or launching a rocket, but you don't have the equation given to you. You have to make the equation. And there are three types of problems that you'll need to know. The first type of problem is an area problem. So example, you have 12 meters of fence for a rectangular area. What are the dimensions of the maximum area you can enclose? So this is an area type of problem. So this is what this question is meaning. You have 12 meters of fence for a rectangular area. So here are four examples. There are an infinite number of possible examples because you can have decimals allowed. Here are four types of rectangular areas that have a perimeter of 12 meters. So 5, 1, 5, 1, 4, 2, 4, 2. All four of these have 12 meters of fencing as their perimeter going around. But as you can see, depending on the dimensions, they have different areas. So this question is asking, if you have to have a perimeter of 12, what dimensions, so what should the length and width be so that you have a maximum area? Now you might remember from grade 9 that the square gives you the greatest area. But for the purpose of this course, we're not really interested in the fact that the square has the biggest area. We're interested in whether you can model this scenario with a quadratic relation and then find the vertex. So if you just answered the square with dimensions 3 by 3, you will not get any marks for this question. So here's what you do. To start with, we're going to have a rectangle because we're going to pretend we didn't know that it was a square. So this is the length and this is the width. So as with all of our problems, we're going to circle the information we have. We have 12 meters of fencing, and we're going to underline the problem. So anywhere you see this word maximum, that tells you we want to find the vertex. So you use the first piece of information to form your first equation. So the information we know is the perimeter. So let's start with the perimeter formula. That's equal to 2 times the length plus 2 times the width. We know that the perimeter is equal to 12, so let's substitute that in. And what you want to do here is isolate one of the variables. Doesn't matter which one you isolate. You can isolate the length or the width. Let's isolate the width. That means the first thing you have to do is subtract 2 times the length from both sides, and you get 12 minus 2L equals 2W. And then the next thing you have to do is divide everything by 2 to get the W by itself. So that gives you 6 minus L equals W. So you start with an equation for the information you know. So we know the perimeter, so that's what we're going to start with. What we're trying to do is find the maximum area, so now we're going to switch to the area formula. Area is equal to length times width. And we know that the length is L, and the width, we just rearrange the formula to be 6 minus L. So because we want to find the maximum, that means we want to find the vertex. And it's the y coordinate. So in order to find the vertex, you have to do one of two things. You have to average the zeros, or you have to complete the square. Now, can you think of which one of these two would be easier? The answer is averaging the zeros. Can you think of why? The answer is that it's already in factored form. If you wanted to complete the square, you'd have to put it into standard form first. So you'd have to use distributive law to get 6L minus L squared, put it into standard form, and then use those 6 steps of completing the square which we did earlier on in the unit. If you average the zeros, there's a lot less steps involved. So let's average the zeros. So because we're trying to find the zeros, we're trying to figure out when the area is equal to 0. These are your two factors, L and 6 minus L. So the first factor, we just have L equals 0. And the second factor, we have L minus 6 minus L is equal to 0. And then if you add L to both sides, you get L is equal to 6. So your two zeros are 0 and 6. So to find the vertex, we now have to average them. Now we would normally use x and y as our vertex, but in this case the independent variable we're using is length instead of x. So it's length instead of x, and the dependent variable is area instead of y. So to find the x-coordinate of the vertex, which is length, you're going to add the two zeros together, divide by 2, and that gives you 3. So that's the length that you should get, which would give you the maximum area, which you can see here when you had a length of 3, that gave us our square with the biggest area. Then to find the area, you have to take that 3 and substitute it into the equation. And this is 9, and it is meters squared. So there you have algebraically confirmed that the square is the rectangle that would give you the largest area. So don't forget to answer the question, what are the dimensions of the maximum area you can enclose? So the dimensions are 3 meters by 3 meters. Now for this question, we didn't actually need this part here because all they asked for was the dimensions, which we get from the L. So you only have to do this part. If you are asked for the maximum or minimum value. Alright, so that's your first type of example, which is an area problem. We're now going to move on to the second type of an example. So example number 2 is what we call a sum or difference problem. So the question says, the difference between two numbers is 8. Find the numbers if their product is a minimum. So here's what this means. There are infinite pairs of numbers whose difference is 8. So 12 minus 20 minus 12 is 8, 10 minus 2 is 8, 8 minus 0 is 8, 6 minus negative 2 is 8, 3 minus negative 5 is 8. But if you take their product, which means to multiply, and just to remind you, difference means to subtract. So if you take their product, so 20 times 12, 4 times negative 4, 10 times 2, you can see that their products are all different. So we want to find which pair has the smallest product, so the smallest value when multiplied. So you can see here from these examples, it would be 4 and negative 4. But how do we know that that's the correct answer? So we're going to use an algebraic method to help us find that. So because we don't have to draw a diagram for this question, we need let statements. So we're going to say let x be the first number, and y is going to be the second number. So again, we use the first piece of information that we know. So we'll circle this. The difference between two numbers is 8. So that means if you take y and subtract x, you're going to get 8. So you use the information that you're given to make your first equation, and now we have to isolate. So let's isolate for y, that would be the easiest. So we're going to add x to both sides, and that gives us y equals 8 plus x. So because we're trying to find a minimum now, that still tells us that we're trying to find the vertex. So the information we knew was about the difference. The information we're trying to minimize or find the vertex of is the product, and the product is equal to x times y. That dot means times. So we just found out that y was equal to 8 plus x. So once again, you can put this into standard form and use completing the square, but the easier method would be to average the zeros. So to find the zeros, we let the product be 0. So your first factor is x. So that means x is equal to 0. Your second factor is 8 plus x. And if you subtract 8 from both sides, you get x is equal to negative 8. So now to find the vertex, the x-coordinate, you add the two zeros together and divide by 2. So that gives you negative 4. That's the x-coordinate of the vertex. And again, we could see from these examples that if one of the numbers was 4, we did get the smallest product. And the other number was 8 plus x, so it's 8 plus negative 4, which is 4. So those are the two numbers that would give you, so it says find the numbers if their product is a minimum, so those are the two numbers, 4 and negative 4. Now if the question asked for the minimum product, this one didn't, but if the question asked for it, our product was equal to x times 8 plus x, and since x was equal to negative 4, you would get that the minimum product was equal to negative 16. So that ends part 1. Please watch part 2.